Okay, let's continue on here. Sorry, I had a little issue. It's called a dead battery in the camera. We've got that fixed, so we'll do part two. Hello, I'm back. All right, let's continue on. So where we ended was we were able to substitute y equals, so the negative 3x plus 19 in for the y, and we get this. And why do we want to do that? We want to do that because now we have one equation, and there's only one type of variable, x. There's not an x and a y, just an x, which means we can solve it. So we're going to go up here and we're going to continue on with it. Okay. In fact, we probably need a lot of space, so let's get rid of this, so we can go all the way up here to the top and continue on. Okay. So 2x. Well, I got negative 5 times negative 3x is plus 15x, and it looks like I have negative 5 times a positive 19. Woo! That's going to be 95, negative 95. Negative 95. And that's going to equal 7. Okay? That's going to equal 7. So, if we put this together now, well, 2x plus 15x is 17x minus 95 equals 7. 17x equals, we're going to bring the negative 95 over, it becomes a plus, right? It's going to become 7 plus 95. So 17x equals 102. And then we're going to have to divide by 17, right? Remember we do this, divide by 17, and divide by 17. And if we do that, we get x equals, 102 divided by 17. Looks a lot to me like 6. Okay, so we have an x value of 6. Okay, that's excellent. How do we get the y value? Well, we can substitute it in here to get the y value. We know that y equals negative 3x plus 19, right? From right there. Okay, so we know, spell V properly, we know y equals negative 3x plus 19. So we can sub in. We can say, so, y equals negative 3 times 6 plus 19, because we just found out that x was 6. And if we do that, y equals negative 18 plus 19, and y equals 1, positive 1. Okay? So now we've found an x value and a y value, and we can say, therefore, do it in purple, therefore, our point of intersection is, well, x is 6, y is 1. So our point of intersection is the point 6 and 1. So if we were to graph it, they would cross at the point 6 and 1. And if you have a graphing application on your computer and you want to try and graph those two things, you'll find that they cross at the point 6 and 1. Now, how do we know we're right? Okay? Can we check it, or we just got to assume we're correct? Well, we can check it. Let me get a different color here. Get a little Christmassy here. We'll go with green. I'm going to just take my point 6 and 1. So what if I put 6 in here for x and 1 in here for y? Okay? Is it true? 2 times 6 is 12, minus 5 times 1 is 5, equals 7. And that is true. 12 minus 5 equals 7. So we know that point does work in equation 1. Question is, does it work in equation 2? Well, now we have equation 2. We'll replace x with a 6 and replace y with a 1. Well, 3 times 6 is 18 plus 1 equals 19. And that is true as well, that 18 plus 1, so we know that 19 equals 19. So this point works in both equations, so we know for sure it's our point of intersection. Okay? So what we've just done is we found our point of intersection using the substitution method. Substitution method. Okay. We'll see you again for the next method. You may need to rewatch this. I know there's a lot of steps and pieces in it. Good luck.